So hi children, how are you all? I hope all you are fine. So children, in that previous video we discussed the problems from that worksheet 2, right? So from that triangles and congruent triangles. So here in this video we are going to discuss about the problems from worksheet 3. So worksheet 3 related to that altitudes, median, so and so, right? So here first, before going to discuss about that worksheet 3, you have to learn that the concept from that concept 3. Okay, that is concept 3 is related to altitudes, medians. Okay, so here concurrent points, what we will call that concurrent points, if that 3 altitudes, those 3 also passes through the same point. Okay, these points, these all things we discussed in the previous videos, no, in that synopsis. So first you have to learn that concept, after only you can answer to this worksheet. If you know that answers, then you also answer to me in that comment section. Okay, so first what is the first question here? See that in an isosceles triangle. So in an isosceles triangle they are asking that isosceles triangle means here any two sides of a triangle are equal. So here what they are asking, in an isosceles triangle, here they given that 4 points, no. So out of these 4 points, what are those? SGOI. Okay, so here SGOI means what? Are the centers centroid and here circumcenter in center. Okay, about that points here directly representing letters they given. So here first one is circumcenter, centroid, and here ardocenter and incenter are collinear. Okay, so in an isosceles triangle, next one, only circumcenter, ardocenter, incenter are collinear. Next one, only centroid, ardocenter, incenter are collinear. Next fourth one, only centroid and incenter are collinear. Okay, so here these 4 options they given, no. So according to that options we can say that in any type of triangle, here circumcenter, ardocenter, and in the same way centroid, as well as here ardocenter lies in that always collinear only. Okay, in any triangle. So here we can say that all that concurrent point lies collinear in a triangle. Okay, so here which option is correct? Yes, option 1 is correct here. Okay, so next one. So say that dash is the equidistant from the vertices. Equidistant from the vertices means, so here when you take that perpendicular bisectors, no need to touch its vertices, no. So here perpendicular bisectors. So what is that concurrent point will be formed after the at that concurrent point of 3 perpendicular bisectors. Okay, so what is that point? What we will call that? Circumcenter. So while I am telling you about that circumcenter, I told you that one of the point, that is circumcenter is always equidistant from its vertices. Okay, here we have to discuss about 2 things. One is incenter, another one is circumcenter. Incenter is always equidistant from its sides. Okay, incenter is always equidistant from its sides. Come to that circumcenter is always equidistant from its vertices. Okay, so here the question is dash is the equidistant from the vertices. So vertices means what? Yes, that is circumcenter only. Okay, if they will ask that equidistant from its sides, then that is incenter. Okay, so here they ask that vertices is equidistant from the vertices they are asking. So here our answer is circumcenter. Okay children, so let us see the next one. Yes, here the next question only they given that dash is the equidistant from sides of the triangle. So sides of the triangle, what is that? When you take that angular bisectors. Okay, so here it's a concurrent point, we will call that one as incenter only, no. So incenter is always equidistant from its sides. So when you take that the distance from its sides, so here for example this distance is equals to d1. So here this is d2 and this is d3. So here we can say that d1 is equals to d2 is equals to d3. Okay, why? Because it is always equidistant from its side. Here we can say that a perpendicular distance also same thing only. Perpendicular distance from that side to incenter is always equal. Okay, equidistant from that 3 sides also. Is it clear to you? So here our option is incenter. Is it clear children? So let us see that the next question. So here suppose G is the centroid of triangle ABC. Okay, G is the centroid of triangle ABC. So centroid means where we can observe that centroid. Here that is the concurrent point of medians. Concurrent point of medians. Okay, so here this is A, B and C. What they are saying here? Here G is that centroid of ABC. Okay, and D is the midpoint of BC. So D is the midpoint of BC. Then AGD. Okay, here they are asking AGD. Okay, according to that options are given: collinear, non-collinear, coincide. Okay, those 3 points not coincide. Okay, those 3 points also lies on that same line. So 3 points lies on that same line. 3 or more points lies on the same line. Then we will call those points are collinear points. So here A, G, D. These 3 points also lies on the same line. No, so we will call that A, Z, D are collinear. Okay, so option 1 is correct here. Okay, children. So let us see that next one. Yes, see here. The number of medians of a triangle. Number of medians of a triangle. So in a triangle, how many medians we can draw? Okay, so we know that how many medians we can draw? In a triangle, medians means a line segment which joins to that vertices to its to the midpoint of its opposite side. Okay. So children, see that number of medians we can draw here. This is A, B, C. In a ABC triangle, here AD is one of the median, BE is another median, so CF is another median. So how many medians are there? 1, 2, 3. So how many medians we can draw here? Yes, 3 medians we can draw in a triangle. How many altitudes we can draw in a triangle? Yes, 3 altitudes we can draw. How many angular bisectors we can draw in a triangle? Internal angular bisectors. 3 internal angular bisectors we can draw. As well as how many perpendicular bisectors we can draw in a triangle? 3 perpendicular bisectors we can draw. Okay. So here our answer is the number of medians of a triangle. So we can draw that 3 medians in a triangle. Is it clear, children? Yes. So see the next question. The medians of a triangle are equal to each other, then the triangle is. Okay, the medians of a triangle are equal to each other. So here they are saying all if you take that a triangle, here they are saying that okay, so in a triangle ABC, here D, E, F. Here they are saying that the medians of a triangle. So AD is a median, BE is a median and CF is also a median. Those 3 also equal to each other. Then the triangle is. So in which triangle we can say that all the medians are equal, all the sides are equal, as well as here all the medians are equal. It is possible only in equilateral triangle. Okay, so here answer is equilateral triangle. Okay, children. So let us see the next one. The incenter of a triangle is determined by the. Okay, so the incenter of a triangle, when we can observe that incenter, that is incenter is the point of concurrence of which lines here? Yes, incenter is the point of concurrence of angular bisectors. So here angle bisectors they given, so that one only angular bisectors. So in a triangle we can draw that 3 angular bisectors. In any triangle we can draw that 3 angular bisectors. So the concurrent point of 3 angular bisectors is called here incenter. Is it clear, children? So here our answer is angular bisectors. Okay, so let us see that the next question. the point of intersection of the angular bisectors of a triangle. Just now previous question they asked that in center is the point formed by which lines they asked. So that is angular bisectors. So here the question they given as when you take that three angular bisectors, it's a point of concurrence. What we will call that? Okay, so what we will call that one? Yes, that is in center. Okay, children, just the same question they given in two ways. First thing they given that in center is that point formed by which type of lines? Okay, formed by which lines in a triangle? Okay, and here they ask that the point of intersection of that angular bisectors. So here we will call that one as in center. Okay, so let us see the next one. Next, the point in the plane of a triangle which is at equal perpendicular distance. So this is also repeated question only. Children, here they given that perpendicular distance from its sides. So perpendicular distance from its sides means, here they are saying that perpendicular distance from its sides. What we discussed about that equidistant from its sides. What we will call that point? Yes, that is in center. Okay, so in center is formed by angular bisectors only, no? So here in center is equidistant. Perpendicular distance is nothing but that equidistant from its sides. Okay, here they mention that perpendicular, but no need to mention that perpendicular. Okay, that is always equidistant from its sides. Okay, children. So here what is our answer? Yes, that is in center. Circumcenter means equidistant from its vertices. In center means that is equidistant from its sides. Okay, don't be confused between those two. Okay, so let us see the next one. So children, see here, in center of a triangle lies in the interior of. So in center of a triangle, we know that when you are taking the three angular bisectors, it's a point of intersection, we will call that one as in center. And in the same way, external angular bisectors if we take, then we will call that one as excenter. Okay, so excenter means that point is formed outside of the triangle, so we will call that one as excenter. And here incenter means the point of concurrence of angular bisectors which is formed inside of a triangle, so we will call that one as incenter. So in any type of triangle, incenter always lies inside of a triangle only. Okay, so that is any type of triangle. Here always incenter lies inside of a triangle for that any type of triangle. So see that what they given in that options, an isosceles triangle only. Here they mention that only. Okay, only means only in that isosceles triangle that incenter lies inside of a triangle. What I told you that in any type of triangle incenter lies inside of a triangle only. Okay, so that's why first one is wrong. And in the same way, a right angle triangle only, again they mentioned that only, so that is also wrong. And any equilateral triangle, that is also wrong. So here any type of triangle, in any type of triangle, incenter always lies inside of a triangle. Is it clear, children? So our answer is option D, any triangle. Okay, so children, see that next one. So here this is also direct bit only. So G divides OS in the ratio. So centroid divides that other center and circumcenter in the ratio. Okay, so that is always 2:1 ratio only. So G divides OS in the ratio 2:1. Okay, children. So see that next one. If the medians AD, BE and CF of triangle ABC meet at G, okay, then G is the. Okay, we will see this question. See here first what they given. If the medians of AD, BE and CF, okay, so we have to take the triangle. This is the triangle ABC. Here they are saying that medians means midpoints. Okay, the line segment which joins the vertex to the midpoint of its opposite side. Okay, so here this is D, E, F. So when you are joining these three, like this diagram you will get. Okay, children. So see here, three medians AD, BE, CF of ABC meet at G. We know that it's a concurrent point. We will call that one as centroid. We will call that one as centroid. And here then G is the, here they given that centroid of a triangle DEF. They are saying that here DEF triangle. DEF triangle means here we have to join that DEF also. So here we can observe the DEF triangle. Okay, children. So here, okay. So let us say that what they are asking, then G is the, so here when you observe this one, here this is that midpoint, here it cuts that midpoint of that AB means, so here also that is passing from that exactly median, exactly bisects only, no, here. Okay, so we can say that here these three lines, what they given here, these three also medians only. So here we can say that G is the centroid of triangle ABC as well as G is the centroid of triangle DEF. Okay, medians means exactly observe that here. Actually we taken here middle point. So here D and G, here something, here nothing we written, no. So this is also one of the median only. Okay, so AD passes through this median. So for example here if you take that as some X. Okay, so X and D, that is also one of the median. Okay, and in the same way here this is that Y. So E and Y is one of the median, and in the same way F and Z, that is also one of the median. So again here we can observe that one of that intersection point of that medians in a triangle DEF. So here what we will call that point? Yes, that is also intersection point of medians only, no. So that's why here we will call that one as centroid of the triangle DEF. We will call that centroid of a triangle DEF. Is it clear, children? Yes. So next one. And here DEF. Here this is not there. DEF with the midpoints of the sides of a triangle ABC. Then the orthocenter of DEF is the, okay. So what we will call, see here, DEF are the midpoints they are saying. So midpoints of the triangle ABC. So first we have to take the triangle ABC. Triangle ABC. And here they are saying then the orthocenter of DEF. So here D is the midpoint of BC, and in the same way E is the midpoint of AC and F is the midpoint of AB. Okay, midpoints only they given. Now then the orthocenter of DEF, then the orthocenter of DEF they are asking. So here when you join these three, here you can observe that another triangle, that is DEF. So here what they are asking, orthocenter. Orthocenter is the point of concurrence of that which lines? So that is altitudes only, no. So here draw that altitudes. This is one of the altitude. This is another altitude, and this is another altitude. Okay, children, altitudes. So here this is that orthocenter. So orthocenter of the triangle DEF we got here. So when you observe the same point orthocenter, observe in that triangle ABC. Actually this is the point of concurrence of altitudes. So we will call that one in orthocenter of the triangle DEF. Observe the same orthocenter in that complete triangle. What we will call this one? So here these altitudes becomes here when you extend this one. When you extended these lines like this, okay, here we can observe that here this is that perpendicular bisectors. Yes or no? These three we can observe here, perpendicular bisectors of the triangle ABC. Perpendicular bisectors. Here we can observe that this is 90 degrees and here this is 90 degrees and this is 90 degrees. So here we can observe that perpendicular bisectors means here also 90 degrees, here 90 degrees and here also 90 degrees. When you observe that total complete triangle ABC. Okay, and perpendicular bisectors, no need to touch its vertices, no, so that is also satisfying, right? So here these three lines point of concurrence. So point of concurrence of three perpendicular lines, what we will call that? We will call that one as circumcenter. Okay, so here this is that circumcenter. So children, don't be confused that in a triangle DEF, here O is that orthocenter. Actually this point is orthocenter of the triangle DEF. When you observe the same lines in that complete triangle ABC, those altitudes become as perpendicular bisectors of the triangle ABC. Altitudes of the triangle DEF becomes perpendicular bisectors of the triangle ABC when you observe this one carefully. Okay, so here that's why this orthocenter become as circumcenter of the triangle ABC. Okay, so we will call this point as a circumcenter of the triangle ABC and orthocenter of the triangle DEF. Okay children, so here our answer is circumcenter of triangle ABC. Circumcenter of a triangle ABC. Is it clear to you? Yes. So let us see that the next one. Yes. Suppose G is the centroid of triangle ABC and D is the midpoint of BC. Okay. So in a triangle, G is the centroid of triangle ABC. Okay. So here ABC, centroid means midpoints, right? So here we got this point like this. So this is D, E and F. So this is that centroid, no? So we will take this one as Z. Now they are saying that AG is to ZD. Okay, so what is that ratio? So centroid divides this line in what ratio they are asking? So that is, we know that 2:1 ratio. 2 is from that vertex and 1 is from that side. Okay, so this is in that G divides one median in the ratio 2:1. Okay, so our answer is AG is to ZD. So that is a 2:1 ratio. Okay, direct question that is. Okay children, so in this video we discuss the problems from 1 to 14, no? So the leftover next questions we will discuss in that next video. So children, next video problems are related to this one only. Okay, so this one again we will discuss in that video. Okay children, so again next we will meet with the next video.